Now I'm going to make a series of videos on sketching rational functions. Rational functions are like functions where you have one thing divided by another thing. So for example, this is a rational function and our job is to sketch this function. So when given a rational function, try and figure out when this will break down, when this whole thing will break down. Well, it will break down when the denominator equals 0, because you're not allowed to divide by 0. So when will this be 0? So set it to 0 and try and figure out when it will break down. So if you add 1 to both sides and then you square root both sides, you get a positive version and a negative version, and then square root of 1 is really 1. So it's going to be positive 1 and negative 1. So this thing here will break down when x is 1 and when x is negative 1. So we know it breaks down. So we know dead on 1 something weird happens, and we know dead on negative 1 something weird happens. The other easy thing to do is to put 0 into the function and see where it jumps to. So put 0 into here. 0 squared would be 0, so that would then give you this thing here, which is negative 1. So when x is 0, it will jump to negative 1. So we know something, well, we know it's going to jump to this point. And then the next thing is to figure out what happens as the graph moves all the way to the right. So find the limit of this as x heads towards positive infinity. So what happens to the graph when you move all the way to the right? That's really x moving to infinity. So so hang on. So let's investigate by putting a big number into the graph, into the function. So put 1000 into here. 1000 squared is going to be very, very, very big, and then minus 1. Well, very, very big number, take away 1, it's still going to be very, very big. So so you've got 1 divided by very, very big. That's going to be very, very small. So you know the further right you go, the smaller it's going to get, meaning that the limit of this is heading towards 0. It's never going to get to 0 because 1 divided by a very, very, whatever big number you put into here, it's never going to reach 0. So we know on the right hand side of the graph it would do something like this. It would do something like this. It's heading towards 0, and we know that it's going downhill because the bigger the number, the smaller it gets. So we know it's going to head towards 0 from the top, and it will always be positive, because when a big number is squared, take away 1, the denominator will always be positive. If the denominator is always positive, and this being always being 1, positive 1, then the overall thing will always be positive. So we know it's going to do this. And think what happens when x heads towards negative infinity, meaning what happens if you keep on walking to the left hand side of the graph. Let's put a big number in here to investigate, negative big. So when you put negative 1000 into here, when you square it, it gets rid of the negative. So you're going to have 1 divided by very, very, very positive big number, take away 1. A very big positive number, take away 1, is the same as 1 over very, very, very big. So this thing here is going to head towards 0, and it's always positive, meaning our graph will look something like this. So we know it passes through here, here. We know it passes through 0, 1, negative 1. So far this is what we know. So far this is what we know. We now need to investigate what happened. Well, we know dead on 1 it breaks down. What happens as you're just to the right, a microscopic amount just to the right of 1. So think of it as being 1.00001. So our function was this. Hang on. Our function was y. Our function was y equals 1 over x squared take away 1. So now a point x just to the right of 1, when you put it into here and square it, it will be very, very close to 1, but just slightly bigger than 1, because when you have a number just bigger than 1, and then you square it, it's going to be a microscopic amount bigger than 1. So a microscopic amount bigger than 1, take away 1, you're going to have 1 divided by, well, if you look at the number line, 0, 1, and then this amount, a microscopic amount just to the right of 1, take away 1, is going to be a microscopic amount just to the right of 0. So this whole thing here will be a microscopic amount just to the right of 0. I don't care. Let's just imagine as this. So now you've got 1 divided by this small amount, and this small amount will be positive because a number bigger than 1, take away 1, is going to be a positive. So this whole thing here would be very, very big. So we know the graph is going to jump all the way up here. So when x is just to the right of 1, it's going to jump all the way up to here. And now let's investigate what happens just to the left of 1. So just to the left of 1 is going to be 0.999999999, let's say 2. So when you put this into here, when you square it, it's going to be a very, very close number just to just slightly smaller than 1. So when you square this, it's going to be slightly smaller, but very, very close to 1. And if you don't believe me, get a calculator and do it for yourself. Put a really, really big put a really, really close number to 1, but just smaller. So and then square it. It will give you a number that's very, very close to 1 as well. Very, very close to 1. Let's just imagine something like this. And then when you take away 1, this is going to be, well, let's look at the number line. 0, 1, 2, -1, -2. So when you have this number here, which is just to the left of 1, and then you take away 1, it's going to jump to here. So your answer would be just to the left of 0. So let's imagine it as being negative 0.000000032, say. So now you've got 1 divided by this number here, which would be negative 0.0000032. So this thing here would be very, very big, but then you've got a negative here, so it would be very, very negative big, if that makes sense. Negative big, in your mind, you've got to think of a big number and then with a negative in front of it. So just to the left of 1 is going to jump all the way down here. Don't forget, it's got to cross here. So we have a hunch that it's going to do something like this. When it's going to do something like this. And then this thing here, we know it's going to be negative big. We know it's going to pass through here. If we use the same reasoning for this point and this point, well, just to the right of -1, if we use the same reasoning, it will jump to all the way down here. And then if we use the same reasoning to the left of -1, to the left of -1, you've got to imagine like -1.00000, I don't know, 27. Just to the right of -1, you've got to imagine negative 0.99999, I don't know, let's say 5. So that's just the left to the right of -1. Well, it turns out that to the right of -1, it will jump all the way down here. To the left of -1, it will jump all the way up here. So we know the graph. Well, we have a good hunch that the graph will do something like this. Okay, so I'll rush through this explanation for -1, but I hope that me explaining this side will allow you to understand the negative side. Well, if you get a graph plotter and plot the whole function, it will look like this. So we know something weird happens dead on 1. It breaks down. So you've got a vertical asymptote, and one's going to shoot up, the other one's going to shoot down. We know that as x heads towards infinity, it heads towards 0. As x heads towards -infinity, it heads towards 0. And we know it breaks down dead on -1. And we know one's going to shoot up and one's going to shoot down. So you get a very good picture of this function without actually understanding the function. Okay.